Hello everyone, this lesson we're going to talk about Y delta three-phase transformer calculation. So here's the connection for Y delta three-phase transformer. The primary, the high voltage side connect in Y, so I have a neutral conduct down here. The secondary is connected in delta. If you remember the phasor diagram we show you and the connection summary, here's the way we connect it. Phase A transformer, H1 connect on line A, H2 connect on neutral. Phase A transformer, X1 connect on line A, X2 gonna connect on line B. Same goes with phase B transformer, phase C transformer, and in this connection, we're gonna have the high voltage side gonna lead this low voltage side by 30 degrees. So that's the phase displacement. Next, we're going to do the calculation of the supply. Three-phase 4-wire, 7.62 kV and 13.2 kV. Low, three-phase 3-wire, 240 volt. Each transformer is 125 kVA. The primary side, line voltage is going to equal to the higher one, the Y, 13.2 kV. The phase voltage is going to equal to the lower number, 7.62 kV. Secondary side, the line voltage is 240 volt, phase voltage 240 volt, because secondary is delta. Delta, line voltage, phase voltage, they are the same. Have 3 transformers, 125 kVA each. For the balanced load, the maximum kVA of balanced load will be 3 times 125 kVA, give me 375 kVA. Now I have this maximum low kVA, I can use to calculate maximum line current and the phase current on the primary and the secondary side. Primary side, put the kVA down there, divide by root 3, and the line voltage, give me 16.4 amps. Phase current, divided by 3, divided by the phase voltage, give me the same, 16.4 amps. Y connection, phase current, line current are equal. Line voltage, root 3 higher than the phase voltage. Secondary side, use the kVA, calculate. Line current going to be 902.1 amps. Phase current going to be 520.8 amps. Secondary side connecting delta. So line current going to be root 3 higher than the phase current. Line voltage, phase voltage, they are the same. Now let's look at the three-phase transformer bank ratio. Each transformer, I have a ratio, phase voltage, 31.75 to 1. Same for the phase voltage ratio. That's the transformer ratio. Now the line voltage ratio, 13.2 kV over 240 volt, give me 55.1 to 1. So you can see we have a Y delta connection. The line voltage ratio is not going to equal to the phase voltage ratio anymore. It's different than the transformer ratio. So you have to be really careful about the Y delta connection. The line voltage ratio is different. Now we're using 200 kVA load to do the calculation again to find what's the primary and the secondary line current, phase current. Put the 200 kVA down there and find the primary line current, 8.75 amps. Primary phase current, 8.75 amps. Because we know it's a Y connected on the primary side, 2 currents are the same. Secondary side, line current, 481.1 amps. Phase current, 277.8 amps. Line current, root 3 higher than the phase current, because the secondary side is delta connected. For so far, you can see I always use the kVA to calculate my line current, my phase current, and you should do that, it's the proper way. You always will get the proper answer. And when you're checking those answers, if it's a Y, so two current will be the same. It's delta. The line current will be root 3 higher than the phase current. So that's the calculation for Y delta connection. If you have any question, you can always chat with us online or send us an email.